message, level, and the process ID as the payload. And finally, we will simply return the response.content. Great. Now, the next thing we need to define is the formatter. So in a similar way, I will define another class named custom_formatter, which will inherit the formatter class of logging module. Of course, we have to import that also. In this class, we will need to define two methods. The first one is dunder_init to initialize the formatter class. And the second method we need to define is format. We must have to override the format method. This method will take the context and the log record statement. Inside this method, we will simply define the format as I want the message, level, and the process ID. So we will simply JSONify it and return as a response. Whenever a log statement is generated, it will automatically call this format method to grab the log format we define here. Great. We are done with our custom log handler with the customized formatter. But we must have to tell the logging module to utilize this handler and formatter. So inside the main section, I will create an instance of custom handler and save it in handler variable. And also, I will create an instance of custom formatter and save it in the formatter variable. Now, first, we will bind that format to our handler. For that, I will say handler.setFormatter and then pass our custom formatter. The next thing is that we will add our handler to the logging. So I will say logging.getLogger.addHandler and pass our custom handler. Great. At this stage, our customized handler and formatter will be utilized in this application. But one thing you should keep in mind is that as we have added a log handler using the addHandler method, in the similar way, we can remove an existing log handler by using removeHandler method. Let's move towards the next milestone, which is set up the remote server application. If you remember that throughout this course we are using two applications, a simple Flask app and the fully functional Bookly application. So why not use this sample app as a remote server? So I will open it in PyCharm. First of all, I will remove the dict-config and related input statement. Another thing is that I have set up the AWS related stuff inside a separate file named aws.py. Let me open it up. You can see that we defined a client to communicate with AWS, and by using that client, we are invoking the Lambda function. Now comes back to the app.py. We will simply import AWS to utilize that stuff. If you remembered that we are sending a post request to /logs route to send our log record from Bookly. So we have to define that route. For that, I will say at app.route and add /logs as the URL path and add the methods as get and post. Then we will bind a view named post_log. Inside this function, we will prepare the payload by using the log record, which will come in the post request from Bookly. Then invoke the Lambda function and return the JSONified response. Great. Now, finally, in order to run this application on our local system along with our Bookly app, which is also on my local system, we need to change the host and the port. So inside the app.run method, I will define 0.0.0.0 as the host and 8000 as the port. That's what we defined as the post URL in Bookly while sending the log record. That's it for the remote server. Let's take a quick look at the Lambda function code so you can get an idea what it is going. I have deployed this function to AWS, but let me show you its code here in VL Studio Code. You can see this function actually making the connection to our remote database, grab the log record we are sending from the remote server, and insert that as a new entry to our logs table. That's it. Also, let me show you that database in DataGrip. Here it is. You can see we have a table named logs, which will take a log entry with a message, level name, and the process ID. Great. Now we are ready to test this entire implementation. So comes back to the Bookly application. I will create a log statement of level warning and add a simple message as this log comes from Bookly. Before running this application, make sure that the sample Flask app, which is actually our remote server, is up and running. So I will come to that and run it as python app.py. You can see this app is up and running. Comes back to the Bookly and run this application also as python app.py. Great. You can notice that our log statement is not here in the console because it's supposed to be in the database. Let's first check the console of our remote server app. You can see here it received a post request at /logs, which is definitely our log record. Now, if it comes to my database and reload the log entries, you can see we got our log record here. Great. We traveled a lot, but we defined a fully functional workflow to manage logging from our Flask applications to the remote server to a database. Before closing the discussion, there's another important thing we should understand, and that's how can we inject the request information to log records. This thing can really help us to debug some errors more appropriately. But how we can achieve that? Let's say we want to add the request URL in the log record, so we can understand from which server our log has been generated. So first of all, we need to change our database schema to store that information. I will right-click on logs table here and click on modify. Now click on this plus icon to add a new column and name it rec_URL, which is type of text, and click on execute. Now we also need to change the Lambda function. So let me pause the video and update that function. Great. I have updated the Lambda function and redeploy that to AWS. Now let's pass that information to our log record in Bookly, from where we are generating our logs. To grab the request URL, we need to get the application request context. So I will import has_request_context and request from Flask. Now inside the emit method of custom handler class, first I will define a variable named rec_URL and initialize it as none. After that, we will inject this information as if has_request_context. Then the rec_URL will be the request.url. Now we need to add this field to our request data. We will grab it inside our remote server, where we are parsing this request and add rec_URL. Great. Let's test this update. I will run the remote server app and we need the request context in order to get the request URL. Flask provides us a way to generate a test request context just for testing purpose, so I will utilize that here. Inside the main section, I will say with app.test_request_context and write a log statement of warning with the message this log comes from Bookly. Now, if we run this application and take a look at our database, you can see that log entry with the request URL. That's how we can inject the request information to our logs. Really fascinating.